My dear student, I am Dr. Kasera taking the class of Bmlt second year, subject biochemistry. Topic is spectrophotometry, and under this spectrophotometry in my first lecture I completed colorimetry. Then I completed spectrophotometry. These two, calorimetry and spectrophotometry, are under the subject of absorption spectroscopy. Here, the light of monochromate nature is absorbed in the solution or in the excited atom. It is known as absorption spectroscopy. Now, today, another technology of spectroscopy is, that is, emission of spectrum. Emission of spectrum may, when we excite the atom of any element, it emits an spectrum, and this spectrum is made to fall on a photocell, and this photocell generates the equivalent current, which is estimated by on the voltmeter or in a calculator computer system. So flame photometry is an example of emission spectrophotometry. uh, Emission spectrophotometry, do you understand the meaning of emission? Where something emits out is emission photometry. Where something absorbed is absorption photometry. So under absorption photometry, colorimetry, spectrophotometry, and atomic absorption spectrometry, these are the example of absorption of spectrum in the solution for the purpose of estimation of different metals, non-metals, or other chemicals and or other molecules of biomedical importance in the solution. Okay. Now another important technology, today I will correlate you, that is flame photometry. Flame photometry is the example of emission spectrophotometry. Emission spectrophotometry, and this emission spectrophotometry has got this part. You see, here is a flame, and through this flame we pass fluid, It is a tentative picture of flame photometry where we developed a flame by passing the fluid in the jet, and it is connected with the air pathway, and this is the sample tank. Now, flame photometry, the source of light. The flame photometry is especially used for the estimation of sodium and potassium especially, and on request it is also used to estimate the lithium. Lithium, one of the important bioingredient for the estimation of level of lithium in mental patient. So basic purpose of application of flame photometry in biochemical laboratory is especially required for the accurate estimation of sodium and potassium and lithium on special request for mental status estimation. Flame photometry. The principle of flame photometry is sodium, potassium, calcium, cesium and earth metal in heat flame atom is excited. When we take the element in atomic state and put on a heated flame, it gets excited, and on excitation of atom it emits certain spectra of light, and this certain spectra of light is made to fall on the photocell, which converts into current, and this current is recorded on a detector, ampere meter. So flame photometry is as good as calorimetry or spectrophotometry, but the difference is that in flame photometry the spectrum is emitted, while in calorimeter and spectrophotometer or atomic spectrophotometry the spectrum is absorbed. The spectrum is absorbed, and so it is known as absorption spectroscopy, while flame photometry is the example of emission spectroscopy. The principle is sodium, potassium and calcium earth metal in heat flame atom excited the light of spectrum, the spectrum specific element on ground state. The atom when on resting position is known at ground state. When they are put in a very high temperature statement in the form of flame, the atom is excited, and this excited atom emits certain spectra. Perhaps you might have seen sometimes when you burn your stove, it gives some colored flame. For example, green flame or even red flame. Why the color of flame is changed? It is due to the nature of the burner. Suppose the burner contains of copper, and the atom of copper when excited it gives green color. Suppose the atom contains of zinc, it gives some other color. So different metals when ionized, they give different spectra of light. So on high temperature the atom is ionized and excited, and they generate the spectrum. The basic principle of spectrophotometry is the amount of light emitted is proportional to the number of atoms or concentration of the element in the solution. The principle of flame photometry is the same as the principle of spectrophotometry or atomic absorption spectrometry or calorimetry. The basic difference is one is emission and second is absorption. So this is the only basic difference. Otherwise, from technological point of view, the basic principle are similar for both the technology, absorption and they follow the Beer's law and Lambert's law. In my previous lecture, I related what is Beer's law and Lambert's law and what is spectrum. So far, if any question occurs on flame photometry, you have to explain your answer in a regular manner of spectrometry and saying that under defined spectrum of light in flame photometry, when the atom are excited by giving the high temperature flame, the atom excited and it emits the spectrum of light, and this spectrum of light is made to pass through the filter, and this light is the amount of light is then fall on the computer, and there we estimate the depth of the color of the spectrum. So this is about the flame photometry. Now in flame photometry, we require some sort of internal standards like sodium, potassium. Here I have drawn a simple figure of flame photometry. You see, this is the source of flame generated by fuel like natural gases, and this is the sample tank. In sample tank we put our specimen, say for example serum, which in this serum we wish to estimate sodium or potassium. We make a particular dilution in it, and from this channel we press the air with a pressure, and after pressing the air, this solution goes up in the flame, and the atom containing in the flame containing in the solution is excited, and they generate the spectrum. The spectrum of light passes through the slit, and after slit they again passes through a particular monochromator light, that is filter of desired spectrum, and after that it is passed through the second slit, and ultimately the transmitted spectrum after absorption on the atom is made to fall on detector, and on detector we read the optical density of the spectrum, and this optical density by estimating the optical density we can easily calculate the concentration of sodium or potassium or lithium present in our specimen by simple calculation. This instrument works follows the Beer's and Lambert's law. Beer's law says that absorption inversely proportional to transmission. So we can take either absorption or transmission. The correlation between absorption and transmission is T is equal to minus log 2. Therefore, if the our detector assembly shows two types of scale, one scale, upper scale indicates the transmission and lower scale indicates the
Absorption.
OD or optical density or absorption. So optical density starts from 0 to 2
100.
because maximum optical density of any solution may not exceed behind 2. So 0 to 2 is of OD, optical density, and transmission is from 0 to 100%. What does it mean? When no light is passed, the transmission, when no light is passed, the transmission will be 0. When 100% light is transmitted, the transmission is 100%.
Sir?
So either we can take reading in optical density or perception transmission, and simple calculating formula is
सर 0 to 3.5 है या 0 से 2 तक ही है?
0 से 2,
0 से 2.
क्योंकि एब्जॉर्प्शन जो है ना
हाँ.
इस इक्वल, एब्जॉर्प्शन का जो फार्मूला है और ट्रांसमिशन एक दूसरे के उल्टे हैं.
Yes, sir.
अगर एब्जॉर्प्शन आपका 100% है तो
जी.
ट्रांसमिशन क्या होगा? 0.
0.
और अगर एब्जॉर्प्शन 0 है तो ट्रांसमिशन क्या होगा? 100%.
100% होगा.
ठीक. अगर लाइट बिल्कुल नहीं निकलेगी मतलब पूरी वहीं एब्जॉर्ब हो रही है. अगर लाइट आपकी पूरी निकल गई इसका मतलब 100% लाइट बाहर निकलेगी. तो इनवर्स रिलेशनशिप इनमें रहता है. तो आइदर यू मे एस्टिमेट द ऑप्टिकल डेंसिटी or you may estimate the transmission. If you take transmission reading, you have to convert it into optical density. The relation has given as T is equal to minus
log 2.
log
2.
2. In advanced fluorometry or spectrophotometry, there are two scales are given on both sides. Lower side transmission, upper side optical density. So direct we take our reading in optical density and calculate. So the Beer's, according to Beer's law, we follow simply that concentration is equal to test reading minus blank reading upon standard reading minus blank reading into factor. Means for accurate estimation we must have some standard in our estimation, and we have then a test standard, test solution, and for which we have to estimate either sodium or potassium, and we process the standard and test under same experimental condition, and put the readings in the formula. The reading of the test absorption minus reading of the blank absorption upon reading of standard absorption minus blank absorption into the concentration of the node. Factor stands for the concentration of node standard. So in flame photometry, one thing is very important, that One thing is very important, that here the spectrum is emitted, while in that the spectrum is absorbed, and this technology is especially used for estimation of and uh, sodium and potassium. But in the process is that first of all we prepare the standard dilution of a specimen of sample, that is 1 is to 200, uh, 1 is to 200, and we use in this technology some standard, internal standard in deionized water. Then we put the electrical connection of the instrument, then turn the air compressor and open the fuel valve. Ignite the flame, ignite the flame from bottom, deionize bottom under nebulizer. First of all, we nebulize or vaporize the water, and this nebulization of water, vaporize or atomize of water, is used as a blank. Then we take a reading of standard by processing under atomized condition and reading of standard, and put the value in the formula test minus blend upon standard minus blend into the concentration of the known standard. So, my dear student, flame photometry, then spectrophotometry, then calorimetry, and then atomic absorption spectroscopy. These 4 chapters we have covered up till now. Regarding these 4 chapters, if you have any question, you are most welcome to clarify your doubts your doubts. I will try to make it easy again. Okay, thank you.